Hello and welcome to the eLab Innovation Podcast, the podcast on e-mobility for research and industry. My name is Simon Voss and I'm the Managing Director of eLab of RWTH Aachen. Coming up, we are releasing a couple of special episodes on the topic of non-road mobile machineries. In short, NRMM. Herein, we present keynotes as well as discussions with several experts from the field. This episode is featuring the discussion at the 6th Annual Electrification Forum for NRMM, hosted in Düsseldorf this year, between the experts Thomas Lüdiger from FEV and Josef Graubman from Ymer Technologies. Herein, we discuss the electrification potential of NRMM, but also point at the challenges and at the current boundaries that the electrification of NRMM has to face. So stay tuned and looking forward to the episode.
I think that we have a combination of a problem. So one is getting enough energy onto the vehicle. Diesel tank is easy. Having enough batteries and being able to package them is and will be still a technical challenge combined with the infrastructure challenge. Because if I have a powerful infrastructure and a good access to infrastructure, I can reduce the battery capacity on the machinery and recharge during the day if the use case allows to. And on those applications where infrastructure is not so readily available or accessible, I need even more energy on the vehicle, on the machinery. So I think it's a combination of getting the right technology into the vehicle, but in combination with infrastructure and improving, let's say, the service as a whole, and not just the vehicle. You need to think it integrally with your energy supply.
All right, everyone. So we're arriving at the end of the second day of the conference, and we would like to end this by having a little discussion about NRMMs and all the topics that we discussed so far. This conversation is recorded. I mentioned earlier that eLab is an innovation network, so to speak, and for that we host a podcast, and we would like to have this conversation recorded in order to publish it on this channel, to also bring forward this very important information that we discuss here to our audience. As you already heard my voice, it's late in the day. But I hope to have an interactive discussion. So Philippe, in case there are questions, is transferring the microphone to you. And I think we will just start the conversation. I may introduce Thomas Lüdiger again to you, as well as Josef Graubman. You already got to know them today. And I will lead through the discussion as the moderator. I will throw in some comments here and there. And so I would say let's get into it. I have a little agenda, so to speak. For today's discussion, we wanted to look at 3 points basically: the technical challenges, the economic potential, and the regulatory requirements. And looking back at today's discussion, I would like to ask you both, first off, where do you see the biggest technical challenge, just generally speaking, from a technological point of view? Is it the battery capacity? Is it the supply chain that we also talked about today? Of course, this is just scratching the surface. I think everyone is aware of that, but just as a reflection on those 2 days, where would you say are the important cornerstones, the bottlenecks, the pain points that we have to address? And you're also all invited to also comment, but I would like to, Josef, first ask you, what do you see there? And Thomas, then as a follow-up, what your view on that topic is.
I have hoped that you asked Thomas first to give me some more time to think about it. I would say the biggest technical challenge for an OEM is to pick the right application to electrify. That is maybe not a technical challenge, but if you pick the wrong application to start electrification with, the chance to be successful in electrification and the chance to put a proof of concept in the market, which is giving you data which you can learn from, is limited. Looking in the technical challenges, I would say it's mostly the organization of the OEM. So today, it's most of the OEMs are rather a diesel-driven organization, let's say like that. They know the diesel very well. They know the diesel application very well. They think like diesel guys, and Electrification, electric drivetrains need to have a little bit different know-how. So it's more software, it's more integration, it's more being open also to partnerships, to share know-how with the sub-suppliers you need on the battery level, on the component level, on the thermal level, of course. And that needs a little bit different mindset. So I would not say it's the technical topics that would have been maybe 4 years different from now. It's more your strategic decision where to go, and secondly, really the mindset in the company and the skill of the team.
So the view of the people which are innovating the technical aspects then.
Correct,
so it's not the technical point per se, but the organization point of view and also, as you said, the mindset. Yeah. Okay, interesting view on that. Thomas, how do you think about that?
I think all the points made are very correct. So when selecting a certain machine to electrify, we have all those organizational issues, but having a different angle on the question asked, I think it is still a technological challenge as well to electrify all the off-road machinery, since there is so many. And I guess pushing the boundaries from the rather easy to electrify machinery, such as forklifts and the smaller ones, the forklifts, and pushing the boundaries towards heavier machinery with lower access to infrastructure. I think that we have a combination of a problem. So one is getting enough energy onto the vehicle. Diesel tank is easy. Having enough batteries and being able to package them is and will be still a technical challenge, combined with the infrastructure challenge. Because if I have a powerful infrastructure and a good access to infrastructure, I can reduce the battery capacity on the machinery and recharge during the day if the use case allows to. Mm-hmm. And on those applications where infrastructure is not so readily available or accessible, I need even more energy on the vehicle, on the machinery. So I think it's a combination of getting the right technology into the vehicle, but in combination with infrastructure and improving, let's say, the service as a whole. And not just the vehicle. You need to think it integrally with your energy supply.
Yeah. So considering your answer, which I think quite differs from yours, Josef, we have the storage capacity issue as well as the infrastructure issue, right? In terms, maybe if I may ask an expert opinion on that. In terms of increase of storage capacity, do you think technical solutions will be available within the next 5 years to allow for full electrification? I think we had a good presentation just now on electrifying tractors, which are kind of more on the extreme case. They are large, they are very remote, they require a lot of energy. So given the evolution, as I coined in my presentation, of an advancements in the battery field, do you think in the next 5 years we will meet the threshold on fully electrifying NRMMs?
Fully, definitely no.
Okay.
But as we are pushing the boundaries or improving the technology, let's say the number of machines and use cases which are being electrified or able to be fully electric is increasing. So it's not there won't be a switch where we are technologically ready to electrify everything. But it will be a development, and by improving the technology, especially on the battery side, but also improving the usage of the machinery and the infrastructure, everything around it, efficiency and everything, it will gradually increase the share of machineries and use cases which are electrified. Will we be there in 5 years to have everything? Definitely no. But it's more the question, how far can we go? How fast can we go there? And it's a journey.
Yeah, so it's a steady improvement. It's not a disruptive process, as I understand your comment, but taking everything that we have and going step by step, improving step by step in terms of energy density. I think volumetric energy density is also a critical part. Or critical aspect. I had 1 or 2 coffee break conversations about that it's not only the gravimetric energy density, but also from a volumetric point of view. And then maybe to sum that up with a little comment on that, and then leading over maybe to you, Josef, increasing efficiency and harnessing all the gains that we can additionally make besides the increase in energy densities by recuperation, for example, smart drivetrains, and also harnessing energy from smart thermal management, right? So
I was laughing a little bit, not on your answer, but I had a situation in mind which I would like to share to the previous question.
Sure.
I had once the chance to bring my son, he's 10 years old, to one of our customers. And the customer is electrifying machineries. And the engineering director gave us a tour through the company, and they have on the same production line, diesel machine and electric machine. And then the engineering director said, do you know what the biggest challenge on electric machines is? And my son said, I don't know. He said, look, this is the fuel tank of the diesel-driven machine, volumetric efficiency. It was like 1 meter by 30 by 20. And he said, and now look at that machine. They had triple the amount of battery space covered. And he said, and what you see in batteries here is equaling not even 20% of the energy you have there. And, you know, being in the industry, you're aware of that. But seeing that two machines side by side, you need that battery development will not be there, that you have the same. So, but he also said, we can today do the same with that machine than with the diesel equivalent machine. And I think that is really interesting from an end user perspective. Okay. And I think that is really where you have to target on. And it's all those small bits and pieces. It's organizational. It's when do you charge in between. So I think it's not the only technology which needs to, and we are all engineers and we always think technically, but I think it's also the organization. You have to educate the customers, and you asked about smart thermal management. One of our customers is doing terminal tractors. The typical terminal tractor driver is driving with an open window. We had this discussion yesterday. And now in a diesel machine, that is not really a problem because, okay, you basically have hot air in the cabin. You drive at 5 degrees outside temperature with the open window because you're used to it. In an electric machine, that equals 8 kilowatt hours consumption, or 8 kilowatt consumption per hour just for heating, just for nothing, because you're used to drive with the open window. And that is not smart. That is just education. That is just changing behaviors. And to answer your question, I think it is also, you need a holistic approach to that machine and a holistic approach to the operation of the machine. So now I'm touching thermal management. It's reusing the waste heat of the drivetrain, for instance, which is a factor which can save you a little bit of power, which you don't have to put in your batteries, which whether gives you more range or a smaller battery capacity. But it's also, again, organizational topics. The diesel driver is used, he's coming to the job site, he's starting the machine, he's ready to go. Okay, it was a cold night, the machine is super freezing, the cabin is super cold, you're maybe even on the charger connection, you do the same and then you wonder, okay, I'm not having full power because I cannot discharge the battery to the maximum, and I'm wasting a lot of energy to get the battery up to temperature and to get the cabin up to temperature. Why I'm not doing that during being on the grid connection where the energy is free? For sure not free, but you don't have to store it in the cabin. And I think that is as conscious. Exactly. And I think those are the things which are, of course, you need to be technically ready for it, but you need to do education, you need to do driver's training, and you need to get also a little bit of mindset change to have the same operational pattern than with a diesel machine.
Yeah, if I may comment on that, because I was sitting next to the guys from Jungheinrich, and they mentioned you cannot imagine how the technology will be used in the field sometimes, meaning how harsh the environment is. And I mean, it comes to, NRMMs are operating in a rough environment, but also, and then I'm coming back to your point, the knowledge about the right use of the technology is not always there. The simple fact that a battery between 20 and 80% of its capacity is a relatively safe range where you can charge fast, for example. So you shouldn't deplete the battery always down to zero or charge it up all the time, or even store the battery, store the battery capacity at 100% under warm conditions. For example, a hot summer month, at 100% capacity retention would degrade the battery relatively fast. We know that from quite in-depth research of our institutes as well. So to circle back to what you just said, I think it comes back to the service point, because as we learn today, the whole sector, not just in its development, what we are considering here a lot, is very complex, but the usage, the whole operation, the optimal operation, considering those small facts like the thermal management of the system, preheating components, for example, or as you mentioned, having a lunch break and then having not 8-hour shifts, but 4-hour shifts for smart management, and then being able to operate for longer on a battery-powered vehicle. So all of this, for me, and maybe you can comment, I invite you to comment on that, comes back to the service point, and this, let's call it vertical integration from a product perspective, that companies, OEMs, for example, include this management aspect into their offering by selling this product together with the service. Maybe we can get those efficiency gains through this type of services. And the question to you also would then be, do you think this is feasible for every company also that is present here today? Or maybe you see some points where you think like, no, the farmer wants to do his own job. He wants to buy the tractor and then be disconnected from any service and any subscription model because he's not willing to have a monthly invoice coming in. So yeah, that's a question to everyone here. I think, Thomas, you look like you want to answer that.
I think, happy to do so. I think all the aspects, as we do know the technology and we know how to handle it best, yes. But I mean, as a matter of fact, if you have an end customer and the end customer can choose between your electrified and battery electric product or your diesel product, and the diesel product is hassle-free, he doesn't have to think about not just himself, but all his employees to work it in a proper way, use it in the proper way, recharge it, think ahead, use it efficiently, and so on. So let's say, giving that burden from an OEM's perspective, selling a machinery with a huge handbook and how to do and a lot of trainings, there is still an inhibitor. Will we go there? Eventually, yes. But I mean, we can sit and say, okay, it's very easy, just train your customers. But the customers might be saying, hey, I'm repelling and I'm going to the next guy buying the easy solution. So yes, we will get there eventually, but there is a huge inertia and saying the end customers and, go to a farmer and tell him what he needs to do. He will tell you, maybe one day I can do it. Maybe even 300 days of the year, I can operate like you want me to, having clear shifts, clear breaks, and so on. But maybe 10 days a year, I don't. Or I have somebody else working with that piece of equipment, and he might operate it differently, who's not trained. And so also having that peace of mind when buying a very expensive piece of equipment is a relevant buying criteria. So yes, we need to educate, and the OEMs need to educate, as we can see it happening in the passenger car and the on-road sector, also in trucks. But it will take some time before everybody is actually trusting in it and is acquainted to operate it in a way. And this will cause an inertia of adoption.
Okay, for the take-up of the new technology. That's interesting. So is there anyone who wants to comment on that? If he thinks that services will be a critical part, or if it will facilitate the whole transition towards electrifying the NRMM sector. Go ahead. Thank you.
From HevTech. Huge questions there, a lot of different things going on.
Yes.
From the end user perspective, it's quite clear that regardless of how much energy and design work you put into the end project, at the end of the day, when you give it to the end customer, you have absolutely no idea what they're gonna do with it. It's just a reality. You can figure out most of it probably, but they will figure out the rest. And you will. So it's going to be an iteration, definitely.
Yes.
Regarding all the what was said about the preheating, for example, that operator comes to a machine, it's cold, it's been connected to the charger, but it hasn't been utilized, as you said. that's I think something that you can work on with the end user and automation. Most certainly, the end user will realize that, well, as you would have a Robusto in your car, it's nice to click it on. At the same time, it will heat up your battery so that you're not in a pickle. And if they set up a time when it needs to be ready, then you will also have a longer time to heat up the battery. So kind of keep up with that situation. But definitely, I think it's most crucial to understand that new users for these electrified machines, same as electric vehicles, is maybe the conception of electricity is blue and it hurts. So it's kind of the normal type of approach that people who are not educated into the products is and I would say that probably this automotive leap into electric vehicles, and people realize that, well, hey, they are working and they are actually not burning as often as petrol cars, for example, even though whatever the papers may say. But it will probably...
You mean the newspapers, right? Not the scientific papers in this case?
Yes, exactly, yes.
So I think an important differentiation there.
Yes, exactly. But I think that's one point that where people will evolve and adopt maybe easier.
Okay. Thank you very much. Interesting perspective. Electricity is blue and it hurts, right?
Yes.
Yeah. So everything that is new has to first be experienced, I guess, until people realize what the benefits are. And yeah, you mentioned the papers, in this case newspapers, which of course always look at, and I had in my presentation a little, I couldn't show it due to time reasons, but what a battery that explodes looks like. Yeah, and that is quite nicely usable for media attention, right, to see a flaming battery. But coming back to the science, it's quite safe technology, and that has to be understood. The complexity has to be dealt with, and then we may see some viable business models.
And maybe one addition on that. Sure. There is a lot of benefits of electric machines. So we talk about the challenges, but if you see the machines operating in the field today, they are quite. So of course, they are basically emission-free. Of course, that is for the end user, for the guy sitting in the cabin, and that is something you should put in the focus in the development, because he is a part of the decision process, in my opinion. But for those guys, it's less vibration, it's less noise. It is, let's say, from a thermal perspective, normally faster heating up and faster cooling down, so it's more comfortable, more convenient inside of the cabin. And those are things I think you should really emphasize. There is one example. We did a lot of testing on an airport with an airport pushback tractor, and the guy in the electric machine said, "Hey, it's the first time that I'm understanding the radio." And that are small things. And if you see those machines operating in the field, there are cases where, when they have the choice, the operator, between the electric machine and the diesel machine, they choose the electric machine. And if you're at that point, I think the battle is won, if you want to say it in that way. But then you have basically proven that those machines are capable. And I think there are some hurdles, yes, but it's doable.
Oh, yes. We so far we talked a lot about the challenges, but there are, as you said, those instances, and we see the same thing. Actually, what's now being electrified, the trucks and so on, and you can see that it's happening in the same way, like in bus depots. Whoever gets the electric bus is the lucky one, because it's not vibrating. You sit in a really vibrating and harsh and noisy environment all day. And this element, by the way, becomes more and more important. And in addition to that, maybe not so much in off-road, but in on-road, also they are way more fun to drive, because the acceleration is just crazy. Also on trucks, because there's so much power density in the electric motors and so on. So they are also fun to drive, and you can make that argument, and we will make that argument also in the off-road. Just to give you an example, right now we have a huge driver shortage both in Europe and the US. So as part of the end consumer game or the fleet operators game, being able to offer a nice work environment, a truck or a nicer to drive tractor or whatever piece of machinery it is. And for example, Walmart, they need to pay drivers right now $100,000 per year because there's a driver shortage. So that's a huge salary they need to pay. And in order just to get the people, the truck drivers, onto the company, offering a better work environment, like a noise-free, nicely to drive electric truck, is an argument and a part of a good business model from the fleet owner perspective. And just one addition in the agricultural sector, if you electrify the implements, you have way more precise dosing of seeds. You have way more precise any kind of auxiliaries you need compared to hydraulic ones. So there is also benefits which need to be pointed out and utilized when electrifying machinery.
Yeah, so then there we are entering the field of like disruptive technology, where the potential of electrifying a drivetrain can have huge impacts not on the topology of the drivetrain, but on the whole setup of the whole concept of agricultural machinery, for example. Maybe to because you were listing like points, so we were talking about challenges, but also potential. So with your arguments, you were focusing on the operator kind of, right? And then putting out incentives with the Walmart example, to attracting your employees or potential new employees to actually do the job, like being the truck driver. But also, for example, from a municipal point of view, when I'm looking at construction machinery or I'm having a large farm where I have my employees, etc. So there are also factors, and I want to point out one example that comes to my mind, which is on the particulate matter. Within cities, for example, when there are construction sites, I pointed out during my presentation that there is actually a problem at construction sites, which is kind of neglected right now, that the particulate matter that is emitted exceeds the general allowable thresholds. So once these health concern topics come more into also, we had newspapers just a minute ago, right? If they are picked up more, if people complain about them, I think then we have more incentives also from that perspective to push forward with electrifying NRMMs even more. Which kind of leads me now to the second point I would briefly touch on. I think that's not such a big discussion as the technical part, but from the regulatory point of view. This is the example, right? The municipality wants to optimize the inhabitant for their, or the environment for their inhabitants. So this might be one as well, especially for the construction sector, I think. So the other question is, what do you think? Will we face from the EU, maybe as a starting organization with this, looking into the direction of stage 6, see some regulatory requirements in the future that may accelerate this transition?
Definitely yes. I think now, and it's not just one or two regulations. It's a whole lot of regulations, I think, which will push electrification of machinery. So, as you mentioned, the more stringent pollutant emission regulations, yes, that will have an impact. But let's say, to be fair also to the combustion engine guys, there is ways at least to significantly reduce pollutant emissions also from combustion engines, right? And this is what will happen and what's possible. So today's and future's diesel engines in terms of pollutant emissions, I think we are on a very good level. But as a matter of fact, exactly in Europe and in the US, it might be different in other parts of the world. Yeah. So I guess just from a technological perspective, to be fair, that's not the most critical thing. But in order to have those low emissions, we have a lot of after treatment, we have a lot of components to be added to the diesel powertrain, which increases complexity, increases costs, and which makes, in comparison, the electrified or hydrogen-based powertrains comparably more competitive as the diesel powertrains become more complex and costly. So that is pushing. And as you were mentioning, I think This is one element, yes. Diesel engines becoming more expensive due to pollutant emission regulation on the EU level or California or USA. Yes. But I think before that, and what we are seeing today on a municipal level, where municipalities just stipulate there might only be zero emission construction equipment on the future construction sites, full stop.
That would be interesting.
And this is happening. Yeah. This is already happening.
In Norway.
Exactly, in Scandinavian cities. And also there are other examples where this is already happening. So, and this is a huge push, at least, for the first construction equipment to actually go mainstream. We're not talking each and every construction site all over Europe is stipulating that, but if there's a few, OEMs need to react on it and offer such equipment. So there is, not just the overall regional governments, or let's say EU governments or EPA in the US stipulating things, but on a smaller scale, singular regions, singular construction sites, which are faster in pushing those technologies forward.
Mm-hmm. So
I have to say I'm not big friend of regulation. So because regulation is always negative in my opinion, because you're forced to do something. Okay. On the contrary, on the car industry, I think it's also helpful because it gives you a clear development schedule on the other hand side. So it gives you that is the big pro side, I would say. I would rather put it that way. I think it will even not be needed in a lot of cases, because what machines today already demonstrate they are cheaper than diesel machines. So not from the initial pricing, but there are applications out there. Terminal tractors, you have a TCO of 1.5 years. Airport pushback tractors, you have a TCO less than 2 years.
But you're talking about the niche markets right now, or?
That are the niche markets. But the question is, why is that possible in niche markets? Why is it not possible in the big markets? If I'm looking garbage trucks, for instance.
Yeah.
That is an application which should be electrified 20 years ago, because the truck is not made for that application. You're in the city, you adjust first gear in the truck, you change your brakes every 2 years, you waste energy like crazy, and there is a total cost of ownership, must be there immediately. And that's what I said with selecting the application is important.
And the mindset.
And the mindset, right? Yeah. And the second thing is also, we're always talking regulation as a negative thing. There are pros on regulation as well. If you see what the Hamburg Harbor is doing now, basically you get priority handling if you have an electric truck there. Yeah. Why not turning it around? Why not saying, hey, there is a benefit, which also does not really need to cost something, because what is priority management costing you? Nothing at the harbor, but you make the harbor a little bit more CO2 free. The other way could be, okay, you make a ban for diesel 4, for Euro 4 trucks or Euro 5 trucks, or you need to pay 100 euros entry fee to the harbor. I think turning it around the other way could be something which would also positively stimulate things. So for the truck operations in the city, you're not allowed to go with the truck in the city, or you're not allowed to work in the city between, 6 o'clock and 6 o'clock in the morning, because it's noisy.
Yeah, I understand.
But with an electric garbage truck, I could pick garbage at 4 o'clock in the morning because nobody hears the truck. So why not working on a positive environment also, which is, again, mindset change and politics and mind change.
Yeah, it's a lot about mindset, as we learned today. Okay, so do you think, then maybe touching on the third big part, I mean, every innovation just comes if it's economically viable, right? So facing the technical challenges, there's the chance on having a value added and basically in the end providing revenue to your organization through your innovation and development. Do you want to say something? No. So my question there is, how much collaboration is needed? Because we learned today also that it's such a diverse field. We were talking about tractors, forklift trucks, agriculture, mining, construction equipment, etc., etc. So many different things, many variants. How much collaboration, from your point of view, is needed in order to bring overall cost? TCO is always the metric that one takes in order to evaluate the economic feasibility, and to get there and to make it economically viable. How much collaboration between industry partners as here, but also between research and industry, do you see fruitful on making the next steps, like all those little next steps that you mentioned, Thomas? Can you draw a picture there? What you envision, what you think would be helpful from your organizational point of view, also?
Yeah, I think yes. So definitely a lot of partnerships in which form ever will be required in order to share investment burden, basically. So, and I think we do have already niche cases where, let's say, electric machinery works quite well, but in order to go the next step into the mainstream of construction and agriculture, there is a lot of work to be done. Improving single technology areas like battery efficiency of e-motors, e-drives, thermal management, but then on the system level, on the vehicle system level, and the entire operation system. So it's a huge task. Having system views, but then also improving every single piece of it and coordinating everything. Yes. So, and this is necessary, and we are starting as an industry to do so. So basically for the mainstream, right now, most of the OEMs, most of the suppliers have been showing that technology generally works, but rather on a prototype level. Now, I think the industry is on the verge to move that into mainstream. And as soon as you want to do that, you're right, you need to be economically viable and make money out of it, and not just greenwash, but actually put machinery into the field. And as you want to do so as a company, you still need to make money. And yes, let's say the huge task to do so is really to see what do I want to focus on, and then build up capabilities to develop all of this on a component level, on a system, subsystem level, and overall system level. So a lot of capabilities need to be built up. A lot of investment need to be done.
Capabilities, also education in a certain way.
Yes. I mean,
so like training for
exactly
like this mind shift that we have to in this direction, or how do you mean it?
Particularly, let's say, in the engineering departments, you need a lot of electrical engineers, you need a lot of software engineers, you need ideally specialists on battery, and everybody wants to have them. So there is a shortage of capabilities in these new fields, just engineering-wise. Yes. And this needs to be built up. That takes time, that takes a lot of money. And what we are seeing is, as we move from that prototype infant stage into mainstream, this becomes more and more of a challenge, and you can do it and you can tackle this in two ways. On the technical side, on the one hand, developing, let's say, modular concepts, for example, modular battery systems, because the single equipment is still on a low volume, and you need to find solutions on the technical side to have maybe one common module, different packs to put different, or one pack then even in different formations on different machineries. So modularity is a way of focusing your capabilities and investments on one modular core and equip a lot of different machineries with that modular core. And secondly, then if you want to do so and you have technical solutions reducing the investment burden, also do it in an organizational way, forming partnerships, OEMs with OEMs, OEMs with suppliers, suppliers and OEMs with research, sharing investment burdens, because you cannot do everything on your own, because it's so costly and allocated to so few vehicles you are being able to sell in the next few years.
Yes, and this modularity point, maybe to just get your understanding, if I understand it correctly, it's modularity within the organization, within your organization, within your product portfolio, but also meaning between collaborators. So going in the direction of standardization, of modularization on a bigger scale? How do you see that? Because Josef, you also mentioned that your solutions within your company are also very customer specific at the moment, right? So you're designing really for the end product. is modularity there a way on decreasing costs and increasing economic viability? Or would you say like, no, it will always be customer specific because those fields are too diverse?
So from my perspective, modularity doesn't doesn't stand against customer specific. You need to modularize smart, right? Yeah. So you find the largest common core, and that's standardized and common, and then you modularize this customer specific. So modularity is not commonality. Commonality is an aspect of modularity. Modularity is actually combining commonality and have a large complexity of products. So I think that helps. And to your second question, whether this is only happening at within one company or intercompany wide. On batteries, for example, let's take the example of batteries. I don't believe too much in actual industry standards. We have been seeing that in the past. There was VDA standards for cells, modules, packs, and that has been decreasing because it's such an integral part of, let's say, competition, the battery, so that really standardizing across competitors is probably tough because everybody, slows down innovation, and the competition will be also on the battery. But there will be partnerships again, so a few companies teaming up, either a few OEMs who might not be, conflicting so much in the end customers' market, so not so much conflicts of interest. For example, and I mentioned that co-sourcing cells, so that there's a few companies teaming up in order to increase sales purchasing volumes of battery cells, for example.
In your talk, you gave that example, right?
And thereby you have, let's say, kind of commonly used components without having an actual industry standard. So there is a collaboration, and the openness to collaboration, I think, will be an interesting thing to see. Because, and we have been seeing that even in the large passenger car sector, on the new fields and software and so on, even BMW and Mercedes are collaborating, which wouldn't be possible 20 years ago, or wouldn't have been possible. And I think that mindset change, be open to partnerships, be smart in choosing your partners, of course, and not everybody can partner with everybody, but that openness, just because at some point you cannot take the investment burden on your own, will definitely be also one key to success in order to roll out a lot of new products.
Yeah. Josef, how do you see that point? So modularity is not commonality. How granular, so granularity comes into play as well, can we be in order to meet, as you pointed out during your talk, the quite specific customer requirements? Because it's the topology of the technical system itself, but also the application, which also, looking at the time variance, is quite diverse, right? You can have one topology which is completely used in a completely different way in two scenarios. So how do you address this from a thermal management point of view, to take this maybe as an example?
To take that as an example, I think that was our leading thing when we started here to develop. And I'm totally with you, modularity is not commonality. So the question is always, there is the nice German word of größter gemeinsamer Nenner. So where can you standardize? What are the parts where you can basically make a modularization? Kleinster gemeinsamer.
Yeah, it's the smallest common denominator.
Thank you very much. I have never heard that in English. So thank you very much. And let's say, to give you an example, for us it's a pump. So we have 4 different coolant pumps which we use in our system, depending on which flow rate and which pressure drop. And those 4 different pumps we use in each and every application. Mm-hmm. And it's for the OEM not a differentiation criteria if he is the only one having that coolant pump, because the OEM alone would not be able to take the investment on that coolant pump, which we have taken as a system supplier in that case. And how I'm using that pump, that's then software, which is also must be modularly built. So I need to have a basic software which I can parameterize to the different application. And of course, I may add on something here, and I may add on something there. And that is the granular part. But the main components, and That is also happening if you look in motors, inverters. There are suppliers, you take the parts from that suppliers, they have made a modular platform there. They get, with more machines being produced, of course, more quantities, which will bring the cost down, which will again increase the business case, or will help the business case. I think one thing which we have not been touching, and there I would see also science and the academic world being more, could help a lot. Okay. It's basically all the front loading. So I see a lot of companies starting now with simulation, building up very sophisticated simulation models, which are at the end of the day should all have the same outcome. Does it make sense to electrify that machine? So that are the simple questions. How do I do it? What is the best topology to do it? And there would be, well, I would hope that science could also push a little bit. Why not having open source there? And then, of course, company A would put a little bit there because they need to have their specific work cases and so on in. But that is something where I would see science also could help a lot in being a driver of the partnership approach, let's say like that.
And I will take that ball that you play over to me right now, and we'll answer that with, and it circles back to the point of collaboration and economic viability in the end, because yes, I see that, and we talked about topologies before in various presentations, and we talked also about customer analysis. So how do different applications look like? I was also talking to my neighbors here, which ask us, do we have models on that? How different technologies are used given different topologies? So I'll take that, and we will research on that. But I think it's very important, and I'm speaking to all of you then, that you give us real life experience that those models can be fed with, because every model is only as good as the input as it receives. So I think that is kind of a good end note on this panel discussion. So as said, everyone is invited on collaboration between industry partners, between research and industry. And yeah, so together we can bring NRMM to the next level and to a bright future. Thank you everyone for attending and taking part in this final discussion, and I wish you a great rest of the day and the conference.
Okay.